So we have been talking about how to build deep neural networks. So today I want to explain two important parts. So forward propagation and backward propagation. So let's go and write some things here. So we have this deep neural network with all these things connected. So we have this is BL. So imagine you have a lot of layers in neural network, like a stack of boxes. Each box represents a layer. Inside each box there are some weights. Think of them as small rocks, and they help neural network to learn from data it's trained on. So let's say we are working with a layer called L. To compute output of this layer, let's call it AL. We call we need to take in activations from previous layers. Let's call it AL minus 1. We multiply those things together, add some bias, and think of it as like small offset. So and then apply activation function to get our final output. So the good news is this process is pretty straightforward. So we just multiply the weights by activations, add the bias, and apply the activation function. This gives us our AL output. But here's important part, where when we are computing this output, we also need to keep track of something called cache or Z. This cache stores value of weighted sum, which is just what we calculated for later use, and in the backward propagation step we'll store this value in our cache. So what is the whole thing? I'll write that down for you. So forward prop we get input a L minus 1, we get output a L, and we have cache of ZL equal to WL L minus 1 plus BL AL equals to GL, and this is our basic activation function. And now we have computed the output layer L. It is time to compute the gradients and derivatives needed for learning. So we call these gradients DL because they represent the rate of change of the loss function with respect to activations at the layer L. To compute this gradient, we need to know how the loss changes when we move backwards through the neural network. So we will take the gradients of our activations, and from previous layer, let's call them DL minus 1. We use them to compute gradients needed for our current layer, which is DL. The good news is that process is pretty straightforward too. So we just multiply the weights by the gradients of activations at the previous layers and add some bias. So apply activation function that will give us our DL output. So here's the important part. When we are computing these gradients, we also need to keep track of something called cache or Z. We already stored this value in cache earlier, so now we just use it directly without having to recompute it. So putting it all together, so forward propagation takes activation from previous layer and multiply it by weights and add bias, apply activation function, and store result in cache. And backward propagation takes the gradients from previous layers, multiply weights, and add more bias, apply activation function, and store cache. So we're going to build on these concepts on the next video. Until then, I'm going to write some math about the backward propagation. So the output will be dA L minus 1, then the cache will be ZL, which will be G L minus 1, GA L minus 1, GU L, GB L. So this is basic how you implement a forward step. So A L minus 1 will be WL BL, then we are going to have AL, then we are going to have cache here ZL, then GAL minus 1, WL BL, GZL, and this is DAL. This will going to be DWL, DBL, and that's the basic thing how we work that the whole thing. And the formula we are going to have the whole thing for WL minus alpha DW L, and BL will equal to BL minus alpha GB L. So that will be the complete thing. So that's all for this video, and see you guys.